Hi, I'm Bob. Welcome back to our solutions to the exercises in the textbook Microeconomics Theory and Applications with Calculus, the 5th edition. We will continue to solve the problems related to the Nash-Bertrand oligopoly model. Here's exercise 5.6. In the Coke and Pepsi example, what is the effect of a specific tax, tau, on the equilibrium prices? The specific tax raises each firm's marginal cost by tau. Coke's Bertrand best response curve shifts up, and Pepsi's Bertrand best response curve shifts to the right. The graph shows that the Nash-Bertrand equilibrium changes from E1 to E2. Each firm charges a higher price. Let's solve exercise 5.7 at a busy intersection on Route 309 in Quakertown, Pennsylvania. The convenience store and gasoline station Wawa competes with the service and gasoline station Fred's Sunoco. In the Nash-Bertrand equilibrium with product differentiation competition for gasoline sales, the demands for Wawa's gas and the demand for Fred's gas are as follows. Assume that the marginal cost of each gallon of gasoline is $2. The gasoline retailers simultaneously set their prices. For Part A, what is the Nash-Bertrand equilibrium? We tackle the problems in two steps. In the first step, we find each firm's Bertrand best response function. Wawa's profit function is as follows. The firm sets its price to maximize its profit. The first-order condition for profit maximization is the partial derivative of profit with respect to its price equals 0. It leads to the firm's Bertrand best response function. It tells us the optimal price the firm charges to maximize its profit for each possible price level its rival sets. Similarly, we obtain Fred's Bertrand best response function. In the second step, the intersection of the two best response curves determines the Nash-Bertrand equilibrium prices. The Bertrand best response curve has a positive slope. The equilibrium occurs at the intersection E. Simultaneously solving the best response functions gives the result. Each firm charges $2.8 and produces 400 units. The market output is 800 units. For Part B, suppose that for each gallon of gasoline sold, Wawa earns a profit of 25 cents from its sales of snacks to its gasoline customers. Fred sells no products that are related to the consumption of its gasoline. What is the Nash equilibrium? The profit from its sales of snacks lowers Wawa's gasoline marginal cost by 25 cents per gallon. The change in the marginal cost will shift the Bertrand best response curve and therefore change the equilibrium. We rewrite Wawa's profit function. The first-order condition leads to its new Bertrand best response function. The other firm's best response function is unchanged. Simultaneously solving the two functions gives the new Nash-Bertrand equilibrium prices and quantities. The firm with lower marginal cost charges a lower price and produces a higher output than its rival. We can also see it from the graph. The fall in marginal cost shifts Wawa's best response curve down. Both prices fall at the new Nash-Bertrand equilibrium E2, but Wawa charges an even lower price than its rival. Let's go to exercise 5.8. In February 2005, the U.S. Federal Trade Commission, FTC, went to court to undo the January 2000 takeover of Highland Park Hospital by Evanston Northwestern Healthcare Corporation. The FTC accused Evanston Northwestern of antitrust violations by using its post-merger market power in the Evanston hospital market to impose 40 to 60% price increases. We know the demand functions for an appendectomy at Highland Park Hospitals and Evanston Northwestern. At each hospital, the fixed cost of the procedure is $20,000 and the marginal cost is $2,000. In Part A, we use the product differentiated Bertrand model to analyze the prices the hospitals set before the merger. Find the Nash equilibrium prices of the procedure at the two hospitals. In the product differentiated Bertrand model, we solve for the Nash-Bertrand equilibrium prices in two steps. In the first step, we find each hospital's Bertrand best response function. Highland Park Hospital's profit is as follows. The first-order condition for profit maximization is the partial derivative of profit with respect to its price equals 0. It leads to its Bertrand best response function. It tells us the optimal price Highland charges to maximize its profit for each possible price its rival sets. Using the same approach, we have Northwestern's Bertrand best response function. In the second step, the intersection of the two best response curves determines the Nash-Bertrand equilibrium prices. In Part B, after the merger, find the profit maximizing monopoly prices of the procedure at each hospital. Include the effect of each hospital's price on the profit of the other hospital. The merged hospital operates like a monopoly. Suppose it charges a single price P in the two places. Its profit function contains only the monopoly price in equilibrium. The first-order condition for profit maximization gives the monopoly price. Suppose the merged hospital can charge different prices in the two places, as this exercise shows. The total profit pie is the sum of each hospital's profit. It contains PH and PN. The first-order condition for profit maximization is the partial derivative of profit with respect to each price equals 0. It leads to two equations with two unknown variables. Solving the equations, we obtain the monopoly prices for the two hospitals. Compared to the Nash-Bertrand model, the hospitals charge higher prices after the merger in the monopoly model. It is consistent with the FTC's accusation. To find one hospital's price effect on the other hospital's profit, we partially differentiate Highland's profit with respect to Northwestern's price. At the monopoly equilibrium, it equals 95. Highland's profit increases by $95 if Northwestern raises its price by $1. Similarly, the partial derivative of Northwestern's profit with respect to Highland's price equals 170, meaning that Northwestern's profit increases by $170 if Highland raises its price by $1 at the monopoly equilibrium. Thank you for watching this video and subscribing to my YouTube channel. See you next time.